welcome to our OSGi track. We've got 2 more talks to go, so this is the second to last talk. I'm glad you could join us this morning. So we have data analytics with OSGi, and which is a very interesting topic. A lot of people are marrying the IoT aspects of OSGi with data analytics, which many techniques for that are written in Java as well. I'm interested to learn about how Bosch and your experience goes. We have Alexander and Alexander, so if you call out Alexander, you'll get somebody today. In any case, gentlemen, take it away.
Thanks. Hello together. We today present our experience and challenge and solution about data analytics with OSGi. Short, I will give you an agenda about our topics that we talk today. We give short introduction about us. We talk about our Bosch IoT Analytics service. We give a closer look about anomaly detection. Afterwards, we will talk about OSGi and how we get data from the ProSyst stack. And the next part is the integration, how we integrate the ProSyst stack with Bosch IoT Analytics. And afterwards, we will talk about the visualization, monitoring, and analytics, and we give an outlook. Who we are? We are Bosch Analytics team. We are located in Germany, in India, and in Singapore. We are a team with different experience. We have developer, we have data scientists, and we have ops people. Now I will hand over to my colleague Alexander. He gives an introduction about Bosch IoT Analytics.
And so we are IoT analytics teams, and our goal is to develop analysis service for IoT data analysis, cloud services for IoT data analysis, and we are part of the Bosch IoT suite, and this is a set of tools, a toolbox for developing IoT applications, and we are here, you can see our icon, and in principle, so these tools exist in Bosch IoT Cloud, so that one can easily provision these services and build an IoT solution or application. And so, as I said, our goal is to develop analysis cloud services for IoT data analysis. And these are some screenshots of our service, our cloud services. And so, in principle, we provide, as usual, 2 interfaces. One is visual interface where people can configure our service and parameterize analysis workflow and so on. And also we provide REST API for using this analysis service from other solutions or applications. Yeah, so the typical scenario is that people or solution architects or developers, they will provision this cloud service in Bosch IoT Cloud or some other services clouds in future, for example in Amazon Cloud, and then they will configure it. And for example, you can see here a list of analysis workflows, and so you can, for example, this screenshot shows how you can configure this analysis workflow for your data. That is, you can define, for example, some aggregation parameters and so on, and then this is the result. But and the second step, actually the most important step, is that you can use this, what you configure here, you can use from your solution or your application using the REST API, and so this is where you consume these analysis services. And this slide actually shows how we do it. So this is a Bosch IoT Cloud, or let's say some cloud, and here we have our analysis services, and then you develop some IoT application somewhere in cloud or maybe some other kind of environment, and then you control what how you use these analysis services using REST API. Typically, you start some analysis job, and this job will run against some data you collect from typically from your devices. This is what it's intended for our service integrated. When you trigger some job, or it will be triggered automatically, then this analysis, one of these pre-configured analysis services will analyze this data, and then it will store the analysis results back to this or another database, and this application will somehow show, for example, display these analysis results, and in this case if we are talking about anomaly detection, then the system will automatically compute an anomaly score for different devices, and it will say, for example, there's this device with this ID has almost 90% anomaly score. It's a relative score, but still we can see that some devices exhibit some unusual behavior, and this is actually a visualization where we can easily represent what actually happens with our devices. That is, these red points represent unusual devices with unusual behavior. And this is how our backend works. That is, we have our own analysis engine developed in our team. It's developed in Python, and this is how analysis, simplified analysis workflow. In principle, the description is quite typical. That is, it's a number of nodes, and each node does some specific tasks. For example, feature generation, feature aggregation, data analysis. But still, but this is what is important. We do not expose these details. This is our back end, which people do not directly control, because our goal is to simplify analysis, not to make it complicated, but to democratize analysis. So these people can have do not have to provide dozens of hundreds of parameters, like how to connect these 10 nodes, or what is the parameter for this data mining algorithm. Rather, we develop some kind of generic workflow. And so we have instead, so we provide in Java this cloud, expose this functionality in simplified form as executors. This is a cloud service, and this cloud service will get its request for user RabbitMQ, and we have a store where we store storage, some database, MongoDB in our case. So we store this analysis model here, and this is approximate. I do not go into details because it's not actually about analysis, it's more about integration with OSGi. That is our experiments, but still it's important to understand what we are doing. So this, what is an anomaly? Anomaly is some kind of unexpected or unusual behavior, and it could be outlier, it could be novelty, and there are different cases. For example, credit card fraud detection, or something. In principle, it's quite general term. That is, it's something that is not expected or has never been seen before, and in principle, it doesn't necessarily some error or some misbehavior. It could be something unusual. So, and therefore, it requires some further analysis. But still, we want to, if we have, for example, thousands or millions of devices, then of course we do not want to monitor them manually. We want to automate this job. And the task of this anomaly detection service is to automatically analyze data sent from devices, and then raise some kind of alarms, so that in this case, these cases have to be further analyzed. So people, some servicemen, or maybe some additional algorithm have to look into details and decide what actually happened. And this is our analysis workflow that we develop for anomaly detection. That is, we use typical anomaly. We generate domain-specific features. Yeah, so this is very important for any analysis. That is, we typically, if we apply data analysis or the data mining to raw data, then the result will be most probably not acceptable, and we need to generate some domain-specific features. I mean, in simplest form, we do not want, for example, temperature is not important at all. What is important is the difference between external and internal temperature, so therefore we generate it here. Then the second problem is that we have normally for devices, we have, not always, but frequently we have asynchronous or irregular events. Yeah, so here different colors represent different devices, and here we have, for example, during each time interval, we have, I mean, we cannot say how many events we will get. So therefore, we aggregate data for each interval and generate aggregated feature, which can be also some domain-specific features. And then we apply some data mining algorithm and then generate, actually find some anomalies. This is about mathematics. So we have several algorithms, data mining algorithms that can be applied to this data, and one cannot say in advance which algorithm will generate better results. But this is one approach. It's called multidimensional scaling, where we have multiple input columns, dimensions, and we reduce them to only, in this case, to only 2 dimensions, and using some analysis. So this analysis means that we actually, for each point, we compute distance. We build a distance matrix between all pairs of points, and then we apply transformation so that the algorithm tries to retain or to have the same distances between all the points, but using only 2 dimensions. And this is the typical results of this analysis. That is, red points are, we can easily see that red points are outliers and probably some kind of anomalies or unusual behavior. But in principle, people can experiment. I mean, there are some other algorithms, for example, one class support vector machine, elliptic envelope, and it's extendable. So it's in principle, it's possible to add your own algorithm into our workflow by uploading Python files. Okay, but that was how our data analysis works. But the focus of this presentation of this talk is about integration. Our goal was to understand how we can apply it to if we have some kind of OSGi platform that is considered as a source of data. Yeah, and we chose such OSGi platform, and here Alexander will continue by describing how we integrated our analysis, how we applied our analysis to these OSGi platform.
Thanks, Alex, for the introduction about our anomaly detection and also about our service. We started our OSGi experience with a POC, and so we want to, in this POC, we want to combine OSGi data with our analytics service. We started with the ProSyst stack, and in the ProSyst stack, when we started, we searched for, okay, how can we get the data, and we read the documentation and looked at the documentation, and for us interesting, we have found 2 ways where we can get the data, which is the custom apps. We can connect over REST API, one way on the gateway, which is interesting when we can do something on the gateway. On the other side, on the backend, where it's completely the data, this is also a part that we want to connect. This was for us interesting that we can also started to get the data over this ways. We used also we read the documentation of the ProSyst stack and mPRM, and our way was we used the RAG event listener to get the data. We listen in this part of event changes, and our connection over the REST API is connected over the WebSocket, so we are able to get all these events and we are able to listen on it. But in our case, we want not all listen to all events. We are only listen to the necessary gateways and the devices behind. And the interesting part for us, we collecting the data of we continue collecting the data of these events. Save them also in the database that we can also use for analytics, and the other part is that also interesting that you can use it for real-time monitoring. Our integration we have here on the left side, we have some Bosch XDKs. These are sensors that have temperature, humidity, pressure, and different parts. We connected them over the gateway. And the gateway data is directly sent to the process remote manager. In our POC, we never see the gateways and devices. It was interesting. We only had access to this remote manager, and we are collecting the data. We see here a multi-cloud environment. We have on one way we have the process remote manager runs on AWS. And our services in our POC is running on Bosch IoT Cloud, and we the gateway sends the data to the AWS, and we connecting to the remote manager and collecting the data here. To collecting all the data, we developed a data collector with the ProSyst as JDK, that we are able to collect all this data. And the data what we collected, again, the data collector subscribes to the remote manager, and the incoming data, in our case, are stored in MongoDB. You can also use other databases for this here. How we do data analysis? My colleague Alexander described before that we have a service called Anomaly Detection, which is run in the Bosch IoT cloud, and this service, we triggered this service in micro batches so that we can start with the small part of data, and we read the data continuously from this MongoDB and write the results to another database that we will use later. For the visualization, this is an interesting part, that what we can do with all these parts that we found in our anomaly detection. Visualization is also important. Perhaps a manager have other visualization view than perhaps an operator. And we also build a solution with this for this visualization. We used here is our data collector that collects the data. Here is the data which is in the database. We run here our batch jobs in the analytics service. The results are saved here. And we use for all this visualization and alerting part, we use Grafana. We used this in this POC, and because it was for our view, we like this tool, that we can build different views for the customer. We can build manager views, we can use views for the operator, and also we can integrate our databases. This was an example of the visualization. This is the real-time monitoring of the XDKs. We see, okay, the colleagues were the XDKs in the other office. They shut down the office, shut down the XDKs, and we have different lifetime behaviors. Here we set some thresholds where we can also create alerts that perhaps push some other things. You see here the alerts. We have here some pressure, we have here the light sensor, and also we have here something else. This is the result. Perhaps Alex can also give some information. This is the result that you also, Alex, showed before. Our Bosch Analytics service has also visualization, but this is directly included in our application. And I think if you build a custom solution or your own IoT solution, it's very necessary that you also can display your own visualization in your own solution. And in this part, we display the anomaly score that is getting from our service. You see here, we have set here in Grafana, I think a threshold about 1.9 or 1.8, 0.8. And if we get a score higher on this, when the job runs, it also creates this diagram. And we use Grafana to send alerts. And this part is another visualization of another algorithm that we also can use in our service. And this is a heat map where we can also display it. The interesting part that we have the OSGi data, we have to do the analysis, and that's the interesting part. So what do we do with the abnormal behavior that we detect? This is a part which depends on your solution. Depends, perhaps in some parts perhaps it's okay that you get an email, in other parts perhaps it's also interesting to trigger a webhook request to your own application that you can work with these results. And perhaps if you are in operation mode, it's interesting to push some notification to your, perhaps to Slack or PagerDuty. Or in other areas, it's also interesting to trigger this notification over Kafka REST proxy to your other solution. Outlook next steps. Our part is we should more learn about OSGi, and also I think in the last days I learned a lot of parts, very interesting part to get data. I think we need some time to read about and get deeper inside, and also a part for what we think is very necessary, that we bring more analytics to the OSGi gateways. And in this part, I think when we have data that is continually coming, perhaps if a real-time monitoring, you have the data perhaps in the cloud. And this is interesting to get. You have in the backend, you have a lot of power. You can also use this to train your models. And our idea is also that we train these models in the cloud and bring these models back to the edges. And I think this is also possible over the API that we can use in the ProSyst stack. And also a part that is interesting to all the developer and DevOps, I think it's very useful that all these guys get also more data science knowledge, and this is I think very important. So please vote for our session, and thank you. Some promotion on 21st and 22nd, there is a Bosch Connected World in Berlin, and there is also a hackathon. I think there are four hack sessions, and I find around 700 people. And if you are interested, contact us. Go to URL. I hope we can see someone from you. Thanks. Any questions?
Yeah, we have time for questions.
Yes.
Any questions for Alexander?
Go ahead. So I know Bosch is very active in the tips IoT working groups. You have a lot of projects and open source. So for the IoT analytics, do you have any plan to open source in tips as well?
This is an interesting question. We also talked in the last day together. This is an interesting part also here in Clips Foundation. What is useful, what is necessary, and also what is interesting for us. This is a very good question. We talked yesterday also about this topic. And also from our side, it's interesting what are other companies doing in this way so that we can go forward on an easier way on this part. But we learned in our experience also when we work with IoT data, there's also a lot of part of data preparation, which is a part that costs a lot of money and also time. And also for us, it's also interesting to get standards on this way so that we can also, the data comes in with the sensor, and perhaps in some way you are doing the preparation, data preparation, and then the other part you do a visualization. And in all parts you need the knowledge about your data. And also when you talk about IoT data, it's also interesting the data privacy, and it's I think very interesting to define something in this way.